Hi, this is Deepa. Today we are going to discuss about multiplexer. Multiplexer is one of the digital circuit. Multiplexer can be implemented using basic gate. What is multiplexer? Multiplexer is a digital switch. It acts as a digital switch. It passes one of the data inputs to the output depending upon the selection line. So data input is a function of selection line. And we are going to discuss about how we can design a multiplexer using the basic gates. This is the diagram for the basic multiplexer circuit. A multiplexer circuit will have n selection lines. If we have n selection lines, the input combinations can be 2 raised to n. Depending upon the selection line, any one of the input is selected out of 2 raised to n inputs and it is given to the output. So basically any multiplexer is a n selection line multiplexer with 2 raised to n inputs and a single output. This is the general diagram for the multiplexer combinational logic circuit. First, the basic multiplexer that we have is 2:1 multiplexer. 2:1 multiplexer has input selection line as A and 2 inputs and output is Z. The A can have a value either 0 or 1. Depending upon the value of A, I0 or I1 is selected. For example, if A has the value 0, then I0 is selected and Z will be equal to I0. If A value is 1, then I1 is selected, then Z will be equal to I1 value. I0 can be either 0 or 1 and even I1 can be either 0 or 1. This is the 2:1 multiplexer. And next we will see how we can design a 2:1 multiplexer using basic gates. This is the diagram for 2:1 multiplexer using basic gates. The equation for 2:1 multiplexer is, if we have this one as the 2:1 multiplexer, output is Y and I0 is one of the inputs and I1 is the other input. The selection line can have either 0 or 1 value. S is connected to a NOT gate and output of the NOT gate is represented by S bar and input is represented by S. And the equation can be written as I0 ANDed with S bar, I1 ANDed with S, and when both are odd, we will get the output Y. Here, this is the S bar. S bar is ANDed with I0. S is ANDed with I1 and both are given as inputs to OR gate, from where we will get the output Y. This is how we can design the multiplexer using basic gates with the help of a Boolean expression. Next is the 4:1 multiplexer. This is the general description of a 4:1 multiplexer. 4:1 multiplexer will have 4 inputs, 1 output, and selection lines are 2. When selection lines are 2, 2 raised to 2 is 4. 4 inputs and 1 output. Here 2 selection lines are represented by A and B. When AB is 0, 0, I0 is selected. When AB is 0, 1, I1 is selected. When AB is 1, 0, I2 is selected. AB is 1, 1, then I3 is selected and given to the output Z. Then Z will be equal to I3. This is how 4:1 multiplexer works. Next we will see how we can implement 4:1 multiplexer with the help of the basic gates. We have seen that when I0 has to be selected, S0 and S1 should be 0 0. So S1 bar and S0 bar are given to the AND gate and are ANDed with I0, and that is given to the OR gate. When S0 is 0 and S0 is 1 and S1 is 0, that is NOT gate output is taken and ANDed with the I1, and that output is given as an input to the OR gate. Next, I2 is S1 is 1, S0 is 0 and ANDed with I2, and given as output is given as input to the OR gate. I3 is S1 is high, S0 is also high, and that is ANDed with the input I3, and output of an AND gate is given as an input of the OR gate. Depending upon the selection line, whether 0 0, 0 1, 1 0 or 1 1, particular AND gate is selected and output of an AND gate is made high, and the same output is given as a output Y. So this is how 4:1 multiplexer can be designed using basic gates. Thank you.